point towards the Hyperledger Fabric implementation with respect to this Hyperledger Fabric with respect to IBM. So we have been discussing certain security and privacy aspects for the same thing. We have seen different components at different levels. Hope you're able to see my screen.
Yes, ma'am. Yes, ma'am.
Okay. So each and every entity will have its own security access that it can take it to by using the keys. Okay, it can secure the access or it can limit the access, in fact, to external entities. Okay, so different entities, you're already aware, there were peers, there were channels, there were ledgers, there were other nodes, ordering services, different entities are there. Each and every entity can be represented as a node, and each of them in turn is having its own security policies. Okay, it is not mandatory for all of them to have follow a single policy. Okay, like if one of them is using RSA, other can use AES or any other security algorithm, but provided all of them must be approved from whom? From the certification authority, right? Because it is a permission environment, isn't it? Just like that, things cannot be developed. Prior permission have to be taken from the environment. Let me wait for another 1 minute if anyone else wanted to join. Okay, so it's just like it's just like a permission has to be taken to implement any of the security policies. Otherwise, again, at a later stage, if it is identified that the permission was denied, but the node has taken the right in order to implement a certain security policy, then it would be removed from the network. Okay, so all that stringent actions and some penalties will be imposed if at all the nodes are violating the rules as prescribed by the environment. Okay, so every environment will have its own rules and regulations. Okay, so proceeding further, some more details about this membership and access control architecture in terms of security aspects. So we have seen in the previous classes that pluggable components are very widely supported by this fabric environment. Okay, pluggable components, whenever you feel that your data is exceeding beyond the capacity of the traditional system, then you can either add what is that, the NoSQL databases. Okay, so based on that, you can make sure that all the things can go on, and whichever entity wants to add some external component, once again by taking the prior approval, it will be doing so. Okay, and membership service providers, yes, they play a prominent role in order to offer various services, but again that should not exceed beyond this architectural guidelines. Okay, whether the services have to be offered on a per blockchain instance or whether they have to be allowed, okay, for only limited number of members from a particular organization. So for every organization there will be a representative, there will be a MSP, but who will be the MSP, that will be decided by the governing body of that particular organization. Okay, so it will be decided by the organization before they are actually onto the network. Access control provision rights, and they can also adopt various languages pluggable components. Okay, if you're comfortable with Python, you can plug in. If you're comfortable with Java, you can plug in those APIs and all that. You can go accordingly, right? And there are different levels at which access control can be provided. As I said, you just when you're developing any project, you have 3 levels, isn't it? You have front end, you have middleware, you have back end, all those things. So trying to provide security at each of these levels is very important. It plays a very prominent role. Okay, so if you're talking about application level security, that is where the users come into picture. Okay, so not all the users should be given access to the entire data residing across the network. Okay, then channel level security is there. Channel level means only the nodes which are using that channel, they can only see the data. All the other nodes which are not connected using that particular channel, okay, just like in this representation. If I say that if this orange lines are representing one channel, then only the peers which are connected to this orange line, only they can access the data available, okay, across the channel, but no other nodes can access the data, okay, associated with that particular channel. So that is how you will try to ensure channel level security. Similarly, if you try to go for chain code level security, chain code level means definitely it will be with respect to the development of the code. Okay, so not everyone should be given access to entire code, isn't it? So there will be administrators who are responsible to provide access to this particular code across the various entities. Okay, because of the public and private access specifiers, and some modules may deal with the financial transactions, and that modules cannot be made publicly available to the end users. So due to that, the administrators, they will play a prominent role in initiating the chain code, in checking out the access permissions associated with the chain code. Okay, then right. So this is how various security provisions are provided, and this is again done based on the permissions that can be provided to users at different levels. Okay, it may be channel level, it may be application level, or it may be chain code level. Okay, so at different levels based on the architecture, we have to always comply with the guidelines of the architecture. So based on that, the security will be provided. Okay, then how will you actually represent the various roles and responsibilities, okay, across the various MSPs? Now suppose if there is a hierarchical arrangement, okay, there may be a root CA. We have seen, no, in unit 3 while we were discussing about the Hyperledger Fabric environment, we have seen about the root CA, isn't it? Various someone is trying to join again. Okay, so we have seen about the root CA, then intermediate level CS will be there. Different levels of CS will be there, isn't it? So, in order to deal with all those levels of users, it is necessary to have a clear understanding of the environment, clear understanding of the rules which have been designed, okay, to comply with the standards of the protocols. Okay, so generally this MSP details, they are basically said to be described by a general interface. That means there is no restriction that only people who are having a particular specialization, they are able to they will be trying to check out, but anyone across the environment, okay, who is really wanting to join the network can try to participate in the interactions across the network. Okay, so the credentials assigned to a user, they need to be validated. Okay, however, user will be accessing based on the authentication, okay, based on the roles, based on the access rights. If they're having permission only to read, then they cannot update the data. However, ledger data is only readable data, but if you want to make changes, then it will be world state data. World state data structure will be preferred in order to modify, so that modification permissions will not be given to all the users across the network. Okay, so in that way, the credentials must be validated. Authentication process is cross-checked thoroughly, whether valid users are joining or not, whether they are hiding their identity or not. All those things will be cross-checked. Okay, and the existing certification authority, like X.509 is a very familiar certification authority. Okay, if you wanted to add some pluggable components to that, because it is a permissioned environment, full 100% flexibility will not be given to the users. Okay, some components are defined. You have to try to add some pluggable components which are compatible with those particular components or with those algorithms which are already existing. Okay, like suppose that X.509 is a certification authority, okay, that has to be implemented across all the organizations. If some organizations are not comfortable using that, then only solution is they have to switch their environment. There is no other possibility. But to that, if they wanted to add some extensions, they can do that. Okay, and the advanced crypto protocols are obviously supported, okay, to go with the user authentication, and the providers that issue multi-signature certificates are also validated thoroughly, right? Now, if you are able to see here, there are two important components. Okay, one is Fabric Core and the other one is application MSP. Okay, MSP is your membership service provider, and Fabric Core is the just like the main coordinator, you can say main central coordinator for that entire Fabric environment. So Fabric Core will be providing two kinds of rights to the users. Okay, that they are verifier MSPs and signer MSPs. So verifier MSPs are basically used to cross check, okay, whether cross check the authentication of that particular user. Okay, so they are used for the any kind of entity, be it a client, be it a peer, or be it a orderer, whether the signatures are valid signatures as they stored in their ledgers or not. Okay, and that is again allotted based on individual channels. Okay, verifier MSPs are used for various entities signature verification on a per channel basis. Then signature or signer MSPs, what are these? They will run locally and extend verifiers with signing capabilities. Once the signature has been verified, then the corresponding entity can perform its function by, yes, trying to process that particular example. Similarly, at the other end also you have verifier and signer MSP. But if it is at the application level, then it will deal with the accessing of computes across various and also by verification of the chain code. Okay, this is at the application level. Signer MSP will run on the client side. Verifier MSP will be used by the chain code. Okay, to just check whether the client attributes, whether they are accessed based on the access rights granted to them. Okay, hope you are able to listen to me and all the things are clear now. Yes, someone can respond. Are all the things clear? Are you able to listen to me? Able to see the screen?
Yes, ma'am.
Okay. Okay, right. Thank you. Then in addition, there is one more component, which is identity mixer. Okay. So this is something which provides anonymity and unlinkability. Okay. A special kind of CA, which is provided by the Fabric. Okay. And as we have seen, the core environment implements verifier and signer MSP. Okay. So the same explanation is here. So moving further, how do you actually represent the standard PKI based MSP? PKI is your public key infrastructure. Okay, so how will you design a standard PKI for membership service provider? Okay, associated with this Fabric environment. Okay, so this is not code, but this is actually some kinds of already available algorithms which are supported by the Fabric environment. Okay, so if you feel that the application which you wanted to develop using Fabric environment, then you should be ready to accept either of these algorithms. These are the available list of options. Because it is not completely an open source environment. Okay, it is allowing you to customize, but not in a complete manner. So for that, you have to check out whether the available algorithms, whether they are compatible with your organization's requirements or not, whether the people in your organization who are running or who are working on a particular application, they are ready to accept this set of algorithms or not. So all that analysis has to be done beforehand. Okay. Now, how to implement this verifier MSP? This is again on a per channel basis. That means each channel may connect a set of entities. So channel wise, the rules may vary, but the algorithms and all more or less they will be same. So identity is verified by using the X.509 certificates. No other option, but only standard X.509 certificate is used to verify the identity. Okay, governed by standard PKI hierarchies. Hierarchies means, as I said you, if there is a root CA, then that is a central controller, just like principal. Now students will approach their teachers. Teachers will approach the head will approach the principal. So that hierarchy has to be followed. Similarly, even here also, whenever a certificate has to be approved, okay, with respect to the validity of the user or entity, any entity, then it has to go through, it has to pass through various hierarchical levels. Okay, right? So in order to set up this particular part, a list of root CAs, because each organization may have a root CA, and a revocation list, which includes the set of operations associated and the admin certificate. So admin is different, CAs, root CAs are different. Okay, admin is just like overall controller, he may be the principal. Root CAs are like heads, and revocation list are the operations associated with each of these entities. Okay. Now, in addition, when you wanted to go for securing, because see, directly you are not storing the plain text. Plain text is not getting stored. Instead, the ciphertext is getting stored. That means you are trying to encrypt the data and then store it before it is getting processed, so that only the person who is having the required key can decrypt and can access the data in order to ensure security. This is a common mechanism, irrespective of whichever algorithm you are using. Instead of storing the plain text, you will be storing the encrypted text, that is ciphertext. Okay, and the one who is having the key only will be able to read out the particular text. Okay, so the support is provided, okay, for this encryption and all by using elliptical curve digital signature algorithm. Okay, and even RSA, reverse Shamir Edelman algorithm also is supported, but it is not supported up to the mark. So by default, algorithm which is supported to deal with the keys and all is ECDSA. And validation, as I said you, it will be carried out by the hierarchies across till you reach the root level, and offers no anonymity support. Okay, so we have been discussing about anonymity, but here, because it is permission, the identity, even if a user has joined, he wanted to take part in the network. Suppose it is just like a faculty who has newly joined an organization, they don't have they are not yet assigned college ID, but they have to perform the exam duties, and what they will do temporarily, they will be getting some. It does not mean that the faculty is a malicious node, because they have been recruited through proper interviews conducted by the interview panel and all. Okay, so they are not malicious, but yes, it will take some time for entire process to take place, to issue the identity to them. So in that case, some temporary identity has to be assigned. Similar is the case even here also. Anonymous users will not be allowed, but if at all, some temporary identities can be assigned to the user before the actual one is issued. Okay, right? Otherwise, they'll be treated as malicious users. Then, for generation or verification of signatures, standard public key crypto operations are used. RSA is a preferable one, so that can be used. And similarly, verification is run at various levels. So these are all the things associated with your verifier MSP. Certification authority must be complying with the X.509 certificates only, and based on the hierarchies, the roles will be assigned. Okay, and access will be assigned to different users. Different operations can be performed by different users, and to access the keys, ECDSA is a preferable approach. Anonymous users will not be allowed to take part in the transactions, and some temporary identity will be assigned to the users. These are all at the verifiers end. Then coming to signer end, more or less it will be at the just as same, but here verification is carried out in the same way as done for verifier MSP. What additional things are used here? Here the standard X.509 certificate with public key, private key. Okay, with that, associated with that particular public key will be added. Okay, the key pairs, just you can say that public and private key pairs are included in the certificate in order to speed up the process of verifying, okay, cross verifying the users. Okay, so this is just a simple representation for the PKI based MSP for the Fabric environment. Okay, is this clear? Yes, ma'am. Let me know if you have any doubts or any other clarification required. Yes? Shall I proceed? Yes, ma'am. Hello. Is responding. Hope my voice is clearly reaching you. Yes, ma'am. Respond to me.
Yes, ma'am.
Okay, right. Thank you. Then coming to the building blocks, this is again an extension of the previous one only, but in detail, as we have seen in our third chapter, how you try to give the endorsements, how do you specify the roles of ESCC and VLCC. Okay, so all those things by using some connectives. Okay, because if you want to give permissions to multiple admins at a time, then you can do that by using the connectives, and or all these are various connectives. Okay. So there are three main principles or three roles that can be assigned. Okay, so one is admin based. Okay, this is not at role based. This is admin based. The other one is identity based, and the other one, last one, is organization based. As we have discussed, based on the entities. Okay, with respect to a particular organization, they will be categorized. Okay, so admin based, so principal can be in this category. Then identity based, so different individual faculties, and representing these organizations may be an authority who is appointed by the principal, right? So a policy can be defined as a combination of n MSP principles, which may be satisfied when the identities and signatures corresponding to T among them are present. That means at least T, okay, identities must be matching among the given n identities, right? And this is a representation. If there are three MSPs, Alice, Bob, and Charlie, then a policy can have the form. Okay, the admin of Alice admin and Charlie member. Okay, they can work in a combination because they might have the similar interest. Hence, they may be given the similar access permissions. It is not that the units of a single organization they should be associated, because see, this is more or less like a consortium environment where multiple organizations they try to work in coordination with each other, so they can interact with each other, they can take part in the similar kind of access control policies and all that. So like that, based on the roles and responsibilities, we can link people together across the organizations in the network. Okay, so that is how you try to build the blocks for access policies. Now, proceeding further with respect to the blockchain crypto service providers. Okay, so what are the various examples of what are the various, I can say, in fact, these are the properties, okay, which enable the blockchain environment to support the crypto service providers. Okay, so it basically supports the features like abstraction is supported, pluggability is supported, but to a limited extent, and multiple services can be taken up. Okay, if one is comfortable with RSA, they can go with that. If other is comfortable with elliptical curve, they can go with that, like that. And international standard support is also offered. Now, why is this term international mentioned here? Can you tell me? Yes? As a developer and as a production environment, what will be the difference? As a development environment, if you are just trying to use the community based services, okay, they will be available for you freely. Okay, you can use them freely, but only limited facilities will be available. Okay, but as a big organization, you cannot restrict yourself, because see, community services also will have security, but it will be limited in nature. Not all the features can be implemented in the. Yes, ma'am? Any difficulty? Hello? Any problem? Okay, so not all the security features will be incorporated into a community service. Okay, only limited services will be available for free. If you wanted to access more higher levels of security, then you have to pay for that. Okay, and that support is available. It is open not only to the people within a country, but even across the world. Because even see, the ultimate intent of any business is to make out profit out of it, isn't it? So to even work, because production team will be available 24/7, okay, for their customers, as the customers are paying for it. Hence, the cryptographic services, the more is the level of security, more complex it will be to implement, and even it will incur the cost also accordingly, right? So international standard support is not with respect to a developer point of view, but for a very big organization, or for data centers, or for where they wanted to deal with every micro granule of that particular security to be implemented. Okay. Abstraction, you very well know, trying to provide a view of only essential aspects. Okay, but all the implementation details and all that will be hidden from the user, right? Then pluggability, as I said, you pluggability is supported. External components can be plugged in, but make sure that they are compatible with that fabric environment without modifying the core. That means whatever are the core, like that of certification authority, okay, as it is supported X.509. If that is a preferred approach, then the user should use that. To that, they can add some more additional features. So the core features, the underlying features cannot be modified. Without that, you can add up some external components. And again, before adding them, again, testing will be carried out. Verification, validation, authentication, all these will be carried out at different levels. Okay. Then multiple blockchain crypto service providers. Okay, so it will allow you to work, because each organization, they may have their own service modules. Okay, they may have their own security modules. So all those can be integrated. Okay, so this is particularly with respect to hardware security module. Security can be defined at different levels. You are very well aware about it. It can be defined at hardware level. It can be defined at software level. Okay. So generally firmware, which is a combination of both hardware and software. So at that level, security can be represented. Okay. So that is how multiple crypto services can be provided. And last one, as I said, you international standard support. Here also pluggable. That is the components which are very well used by that particular organization in order to ensure the fine-grained security aspects. Okay, they can be plugged in, but yes, they have to bear the expenses, right? Okay, so as a user or as a developer, as if you are working on any project, then you can focus on first three aspects. Okay, abstraction, however, will be provided. Pluggability is supported, where you can add in some of your familiar environments, fabric environment, and you can also try to integrate multiple security aspects. Even this may not be complete, but you can check it based on. Okay, if it is educational organization, entities may be different, access roles may be different. Okay, so for that, what algorithms can you consider? If it is a healthcare, then for that, which kind of security aspects you can consider? So all that can be decided based on the nature of the application and also the roles and responsibilities of the entities. Okay, right? So that is how this BCCSP feature is supported. Hope the things are clear so far. Yes, ma'am. Any doubts, you can let me know. Yes? Are all the things clear? Yes? Hello? Are the things clear? Yes or no? Are you able to listen to me?
Yes, ma'am.
Okay, fine. So proceeding further, even you can see security, as I said you, it can be differentiated. Okay, you can take up security differently for different components, or for hardware it can be different, for software it can be different. Software, definitely it will be with respect to the code. For hardware, at component level, you can go for some additional level of security. So in order to bootstrap, you very well know what is bootstrapping. Okay, when the OS is loading, okay, from the disk while you have turned on your system, okay, that is the boot time. And bootstrap is where a program keeps on running at the background. So where whenever the loading process is taking place, even then also some security algorithm can be run in the background in order to keep away the unwanted viruses or Trojan horse, okay, malwares, all these running in the background. Okay, so what are the tools that help to bootstrap a particular network? Okay, so here you can see two familiar terms. One is cryptogen. Okay, so this is used to generate the crypto material with respect to X.509 certificates and the public keys and private keys for different entities. This generator will take care about generating the certificates and the keys. User need not worry. Okay, if just anyone is having an experience of using your Amazon Web Services or any other service provider, then once you are trying to register, okay, and you are trying to start using that particular environment, automatically the environment itself will assign you the keys. You need not worry about the creation or generation of keys. Yes, but at the other end, if the organization itself, if they don't want to completely rely on that particular environment, then they can also create their own keys, but it will again add a burden. Okay, because they should understand what is the nature of algorithms. Definitely, it will be hashed, then it will be encrypted, and again, lot of time will be consumed in identification of all these aspects. Okay, so hence it is essential to use some available service provider just like cryptogen, which will generate the required keys and certificates for different entities. Again, here it can be for channels, for peers, for validating nodes, for ordering nodes, for endorsers. Okay, so they are all different entities, right? Then there is one more term you can see here is config tx gen. Config is configuration, TX is with respect to transaction and generator. Configuration transaction generator, what it will do? Okay, so this is basically designed to configure the network. Okay, just like that, as I said you, because it is a permissioned environment, nodes cannot be added on the fly. Okay, they have to be cross-checked thoroughly, and the roles, responsibilities, all that have to be clearly defined by the authorities, and then only they will be added. So there, this config TX gen will also play a prominent role, okay, to configure the network with the organizations included in the ordering service. Among 10 organizations, if only 3 are included in the ordering service, then for them the network will be configured. For remaining rest of them, the configuration will not be carried out as of now. Okay, so based on the priorities, based on the task which has to be carried out, configuration will be carried out by this particular tool. Okay, and where it will be residing? Yes, with respect to modifying the things in the Genesis block. You very well know that Genesis block is the first block of the blockchain, which will hold all the metadata. Okay, it will not contain actual data, but it will contain metadata. Okay, so hence the configuration details, which block will, which entity is given, which particular kind of access rights, all that will be represented in the Genesis block. Excuse me. And it will also generate the configuration transaction artifacts used for channel creation. Okay, so how a channel can be created? What are the things that have to be represented for creation of a channels? Okay, which peers, which entities can take part in that particular channel based on their access rights, based on their permissions. Okay, if they are allowed to read, they cannot modify. If they are allowed to modify, they should not get admin rights. So like that, roles and responsibilities will be defined. And based on that, again, the configurations. It is just like whenever you are trying to install any software. Okay, if you wanted to make any changes, if it is an open source, then which file will you modify? Yes, configuration file will be there, isn't it? Yes, config.yml, something, some representations will be there. So config file, similar case is here also. Okay, so this config txgen is like a config file, okay, which can be modified in order to include the roles and responsibilities of different entities, access permissions to different entities, and all that will be coded into the Genesis block. Okay, so this is also taken as a network bootstrap 2. So this all will be loaded when you are trying to run the software in the background itself. Okay, at the boot time itself. So these are the two tools to bootstrap a network to strengthen the security: CryptoGen and Config TXGen. Don't get confused between the roles and responsibilities. Okay, the second one is having more broader roles when compared to the first one. Okay, is that clear now? You understood the differences here in between them? Yes? Yes or no? Hello? Able to understand? Yes? Say if you're not speaking, I am not knowing whether there is any difficulty at my end or your end. So someone must be respond out of so many participants. Hope all the things are clear. Shall I proceed further?
Yes, ma'am.
Okay, okay, right. Thank you. Then, generally, you may be confused about where to start up. Okay, how to actually incorporate privacy and security and all. As I said, we have been discussing so many things with respect to security, but privacy again, it is just like a narrower version where you can provide privacy with respect to the following entities. Okay, in terms of transaction, you can provide in terms of state representation, in terms of coding, that is smart contract, and in terms of providing access to the user. So these are 4 levels at which privacy can be provided in a blockchain system. What do you understand by transaction data privacy? Okay, so transaction data privacy is like trying to check each and every execution of each and every action, okay, of a particular entity. The just like you have a log record, isn't it? Entire data, whatever you are, whenever you're running any software or you're using anything, at the admin end there will be a log record, so that in the event of failure you can check the log record and you can again restart or resume your operations. So this transaction data privacy is also associated in the same way, where the kind of actions or activities executed by a user, okay, they will be defined based on their roles and responsibilities. Okay, in fact, any action or any execution which is carried out by the user is a transaction. Okay, so that will be cross-checked. What transactions, what transactional activities can be performed by the user, that will be dependent based on the access control given to the user. Okay, read, modify, update, all those things with respect to your the query languages. Okay, because you even have a possibility of injection, SQL injection attacks and all other attacks to take place, isn't it? So by restricting to this particular type of privacy, those attacks can be kept away. Then state data privacy. Okay, state data privacy is the chain code or smart contract data. Okay, the data that the smart contract alters, whether the entity which is having a smart contract and modifying some values of variables. Okay, it should do that again with respect to the access control given to that particular entity. Okay, so state data privacy is with respect to the modification of the data present in the code, that is modification of your smart contract. Okay, so based on the access control, modification is allowed, otherwise it is restricted. Then smart contract privacy is with respect to the modification of the logic. Okay, who and which entities, just admin will be given that right, not all the people will be given the right. So this is very peculiar and very prominent one. Smart contract privacy, where the logic, see, state data is with respect to the variables modification and all, but entire logic itself, okay, the flow of data from one module to other, all that can be controlled by this smart contract privacy, which is basically the heart of any project development. Then user privacy, checking for the anonymity and unlinkability. If they are not associated with that particular channel, but still if a user is trying to involve, then that is unlinkability. Anonymity, if they are not yet revealing their identity, though they have come into the network, but they are not revealing their identity, then all those things should be eliminated. Okay, so these are the 4 segments I can say where privacy can be ensured in a blockchain environment. transaction with respect to the execution of each and every action, state data with respect to the modification of data inside the code, smart contract privacy with respect to the modification of entire code itself, user privacy with respect to the user identity, and access control rights. Okay, none of these aspects, you have to note that none of these are supported by permissionless platforms, including Bitcoin and Ethereum. Okay, Ethereum, it has drastically changed in past 2 to 3 years. Now you can see that Ethereum is also offering security up to a greater extent, but not as offered by the permissioned environment. So all these features are not completely, we cannot say that they are completely ignored, but yes, they are partially supported, I can say, partially supported by the permissionless blockchain environment, except pseudo anonymity. Okay, as I said, you identity, if it is not available, it can be assigned on a temporary basis, and it is completely, applications have to handle them, means it is the headache of the developer. Okay, developer have to break their head in order to implement the privacy in terms of the above mentioned aspects, if at all they are using either of these platforms. Bitcoin is, however, is not preferable one. Okay, but Ethereum is a preferable environment for a person to start understanding the flow of actions across the entire network. Okay, so important aspect of permission blockchain platform, targeting enterprise applications. So permission, if you're using Hyperledger, then yes, you can ensure security for some good amount of applications. But yes, if you want higher level of security, then you have to convert into production environment where you have to pay for the services that you are using. Okay, so these are the various things that I wanted to discuss today. Just we are left with very few things, ma. We will finish it off tomorrow. So open for discussions. Any doubts, any clarifications required with respect to whatever I have explained, please let me know. Yes, ma?
No, ma'am.
Okay, hope all the things are clear. And once again, I will just let me update you about your second mid syllabus. Second mid syllabus is the leftover part of your third unit, that is Hyperledger Fabric 2. From that part onwards, till entire fifth unit, including fourth unit and fifth unit. Already the notes is shared with you, so please go through it thoroughly. But still, my suggestion is don't depend on that completely. Try to explore more. Okay, try to explore and try to gather the data, okay, properly as you can. And for your slip test mostly it will be scheduled on Saturday, ma. So Saturday your syllabus for slip test will be units 4 and 5. Okay, and tomorrow mostly within half an hour we will finish off our syllabus, and then I want the people to take up for revision. Already, I think some of them have filled in the sheet, so they can take up. See, it is just like helping out your friends who were not present for the initial classes, nothing more. Okay, hope it is clear. Any doubts, any clarifications, ma'am, with respect to the syllabus or with respect to any other content? Please let me know. Yes? Are all the things clear?
Yes, ma'am.
Okay, right. So let me proceed with the attendance then. Okay, roll number 1. 1 is absent. 4. Please be attentive.
4 present, ma'am. 4 present, ma'am.
Okay, 11.
Ma'am, 11 present, ma'am.
Okay, 37.
Present, ma'am.
38.
Ma'am, present, ma'am.
49. 52. 54.
54 present, ma'am.
55. 55. 60. 61.
61 present, ma'am.